So the last section. So theoretical probability is really the same kind of thing as experimental probability, but experimental probability is you do the experiment and what you get is the probability. This is saying according to the theory, what should it be? So you're not actually doing the experiment, you're just saying, oh, if I flip a coin, the probability of getting heads should be 50%. As opposed to actually flipping a coin 50 times and figuring out how many were actually heads. So, okay. So probability, Roman numeral 1, equally likely events are all the possible equally likely events, all the possible outcomes have the same chance of occurring. Looks like I need two R's. So same chances of occurring. So flipping a coin is just like my random example of one. So you could say yes if you wanted to. Unless you could somehow weight the coins, one side should be just as likely to land as the other side. Fair enough? Yeah. So the equation then for that, in blue maybe, so theoretical probability equals, so basically you look at the number of ways to get your outcome. So number of ways to get your outcome. So if you're talking about flipping a coin and having it be heads, there's just one. It can only land on one side being heads. If you're talking about rolling a die and having it be an even number, if it's a six-sided die, you have 3 would go on top. And then the denominator is going to be the total number of equally likely outcomes. So if I were to try to shorten that, I'd probably say the number that work divided by the number possible or something like that. You're probably not going to be actually writing this equation out and filling things in with it, so I figured I just would go long and the best description rather than try to make it shorter. So your chances of rolling a 4, the theoretical probability would be 1/6, because only one side is a 4 and you have 6 sides on a normal die. Your probability of rolling an even number would be 3/6, but we should reduce the 3/6 to 1/2. And for each of those, if you wanted to, the 1/2 would be easy. What percent is going to be 1/2? 50%. So after that one, you could write 50%. So 1/2 or 50%. If you wanted to, you could take your calculator and do 1 divided by 6 and get 0.16 repeating. So this is 0.1666666, or that's about 17%, or a 16.6 repeating percent chance, or something like that. You okay on those?
Yep.
Cool. So let's say we have this experiment to flip a coin 10 times. The theoretical probability would be, well, this notation right here is saying what's the probability of it landing heads? It should be, I'm just going to do a fraction and say 1/2, right? So 1/2. The probability of it landing on tails would be 1/2. So if you take those two probabilities and add them together, you have 1/2 for heads plus 1/2 for tails, you get 1. And if you took the number 1 and converted it to a percent, it would be what percent?
1.
Yeah. So really we're just kind of saying over here, I'm going to squeeze it in there, it's 100% chance. You have a 100% chance of flipping a coin and either getting heads or tails. Unless you're a stickler and you try to, but it could land on the edge, but I've never seen that happen. But okay, we're still good? Cool. Experimental probability then. Oh, I should switch something to blue. Let's go to yellow. I haven't done yellow yet. Experimental probability would be, let's say you actually flip the coin, you get heads 4 times. So that's going to be 4/10. Fair enough? So experimental probability. Let's say we get 4 heads, so it'd be 4/10, or if you wanted to, you could reduce it to 2/5 would be a better answer. If you have heads 4 times, that means you have tails 6 times. Reducing that to 3/5 would be a better answer. But if I were to say 4/10 plus 6/10, that gives me a 1, which is the same as 100%. That if you add those two together, you have 100%. But So experimental probability is what you actually get in your experiment, and it might not match up to the theoretical, what it should be, what the odds would be. Still good? Cool. This next part seems a bit hokey to me, to be honest. They say so I'm going to do that P with the parentheses again, so the probability of an event happening plus the P, or the probability of an event not happening, so if you notice, I've wandered over by those guys in the back left a couple times because they've been talking while I'm teaching. So there's this probability of them talking again, so I need to wander over there. That'd be the probability of the event happening. But there's the probability that they won't start talking and I won't have to wander over there again. If I would take the probability of having to wander over there plus the probability of not having to wander over there, the total would be
100 to 0.
1. Or 100%. Because maybe there's an 80% chance here, 80% chance I have to wander over there like I'm doing right now, and there's a 20% chance of them not, which you add the 80 and the 20, you get the 100%, right? Which 1 is a number is 100%. So it seems kind of hokey, but supposedly you can use this in your brain to say, okay, if there's a 40% chance of rain, what's the percent chance it's not going to rain?
60%.
60%, where most of it's just kind of like, why do I need the equation? I can do that in my head. But does it at least make sense?
Yeah.
40% for one, so the other is going to be 60%. And you could, if you wanted to, put that in here and say, if you're going to do it as the percentages, it'd be 40% plus X equals, over here we'd have that it's 100%. If you wanted to do that instead as the decimals, for those it would be, you could say 0.4. No, I'm sorry. Yeah, 0.4 is the 40% plus X equals 1. Solve for X, you get 0.6, which then is 60%. Fair enough?
Not fair enough.
Okay. Page 2. This is where I think it gets to be a little bit more fun, maybe just because this is newer for me. I've done probability before. Odds, I really haven't done much in teaching up until now with this stellar group. Okay, odds. If you have odds, they predict the likelihood of something happening. So, of something happening. Look at my notes. I was going to write it up above. So, kind of how they write it. So, I'm going to say written. You pretty much can kind of do it the way we could kind of do ratios, because percents are really kind of ratios. So it could be something like a 3 to 1 like this here. So 3:1 would be like a 3 to 1 odds, that it's 3 likely that it's going to happen, 1 likely that it wouldn't. So 3 times more likely that it's going to happen. You could also write it out as 3, 2, 1 like that. Or you could write it, as you have those ratios, you write them as fractions. Agreed? Yep. So if we're looking at the odds of winning a game, the equation when you're talking about odds is similar to but different from the equation for probability. And that's really, you got to pick up on that. So I'm going to switch to orange for dramatic emphasis. Odds, the numerator is the same. It's the number of ways in favor. In other words, it's the number of ways of getting what you want to get. Or I'll write maybe success in parentheses. So basically it's the number of outcomes that get what you want. But the denominator, instead of the denominator being the total possibilities, it's the number of ways to fail. So if we're looking at that, here. But we had said, you could write it as a fraction like this thing up here, or you could write it as one of these ratios. Well, if you write it as a ratio, I'll try to squeeze in, it's just the numerator, number of ways for success. Then you could say 2 or put in the colon, number of ways to fail. And that, to me, doesn't feel real clear yet, but if we go and look at it, example 6, that'll make it a whole lot easier. So what's the odds of it being a weekend? Well, how many days are on the weekend? 2. So the number of ways in favor would be 2. How many ways are there to fail with it being a weekend? 5. 'Cause there's 5 days that aren't a weekend. So your odds then would be a 2 to 5. Or you could write 2 over 5 or 2 and then the word 2. 2, 2, 5, something like that. But you okay for odds?
Yeah.
So the denominator, or the second number now, isn't the total anymore. It's the ways to fail. You could take and do this thing here is really just going to be the reciprocal of that. The odds against are going to be, well, what are the odds of it not working out? Or what did I write in my notes? You have the odds of something not happening. So not happening. And for that, you really just flip that fraction over. So now the numerator is going to be the number of ways to fail. So number of ways to fail. Because you're saying, what's the likelihood of failure? Number of ways to fail divided by number of ways to succeed. Or you could say number of ways in favor if you wanted to, like I did before. So if we're looking at the odds against drawing a face card, just to make it a little bit easier, I took and put all the cards over here on the right. And I wasn't sure about ace. Is an ace actually a face card? And the official version is no. It's just jack, queen, king, and if you're using jokers, but we'll leave those out. So what's the odds against drawing a face card? Well, how many different types of cards could you draw and have it not be a face card, to fail to draw? So it'd be 10. Especially if you put the ace up there by the 2, it's a little easier to count. But ace to 10 is going to be 10 cards. The ways to succeed would be 3. So it'd be a 10 to 3, or you could do a 10:3 or a 10 to 3. So those would be different ways you could do odds. So odds for, you put the ways to succeed on top. Odds against, ways to fail on top. Good? And the very, very, very last section. So converting between probability and odds. So if you have 1 to 9 odds of getting a ticket your first year driving, nothing. Okay, so 1 to 9 odds of getting a ticket, and we want to change it to probability. Well, probability, we said was, so our probability was the number of ways over the total. So what's the probability of getting a ticket? The number of ways would be 1. What's the total? 10. Yes, because 1 person does, 9 people don't. So the total is going to be 10. So it'd be 1/10 for a probability, or you could do the math and change it to 0.1 or 10%. So there's a 10% chance of getting a ticket your first year of driving. If you're late for curfew, don't run a red light, because it's 3 points on your license. And if the several $100s doesn't kill you, what it does to your insurance will. Insurance goes up a lot. Okay, number 9, example 9. If you have a 25% chance of your teachers bringing in food on exam day, what are the odds in favor of it? So number of ways. So if we're talking the percent chance or the probability, so number of ways over the total is going to be my 25%, yes? 25% is 1/4. I should have said it is as a fraction, but it's 0.25 or 1/4. So if we want odds in favor, so that was our probability or our percent on the one side. If we're talking odds, basically we're looking for success, number of ways for success over number of ways to fail. Speak to me. Number of ways for success would be 1. Number of ways to fail would be 3. Because 4 is the total. So if 1 is a yes and the total is 4, do you agree the chances against would be the 3? So it's going to be a 1 to 3, 1 over 3, something like that. Or a 1, 2, 3. And you don't have to write the answers multiple ways. Pick away and write it. That's it.